Good morning. Where is everybody? Guess I have to send a reminder? Surprised. I'm not supposed to send a reminder. Everyone should just pop in. People are starting to come. I'm not sure why I can't log in to something here. Okay. So if you see the screen getting blurry, the feed is blurry, just reload. Reload the page. Sharpens it up. Good morning, Xavier. Hello, Tiana. Hello. Good morning. I'll wait for about 20 people and then we'll start. So what we're going to do is solve this problem with inflation. And then, good morning. And then we will go back and finish the notes. The notes where there was a remaining problem called the pension problem, or I don't know how anyway, it's on pensions. And then we will go, and using your calculator, and then we will go into the new notes, the last set of notes I gave you. Good morning. Morning. Let me know how the sound is. Last time it was kind of echoey. How do you find the volume or the sound? Okay. The thing is, there's just the interference of the noise from the fan on this computer. I don't know if I should turn it off. I have a way of turning it off so it's not so noisy. But I worry about it overheating the computer. Okay, so just waiting for 20 people. We might not reach 20 people, so I'll just start. Okay. So this is where we left off with this problem the other day. And I had suggested that you solve this expression, right? So that was the logic of, this was the normal, sorry, not normal, the nominal set of cash flows. That's the timeline for the nominal set of cash flows. And then I said, that was part A. And then the second part, using the real cash flows, so I adjusted them for the inflation, and it demonstrated they were going down, right? They're going down. They're less and less and less here. I've circled them. And by a factor of deflation. So you're deflating for every period that inflation has eroded the purchasing power of your money. So you have less and less to buy stuff. So then I asked you to prove you get the same result. Now the result here, the result was $2,103.32. So we have to see that we can get that with these amounts. So I said we need to use, it's because we want to use the real annuity, we want to use the growing annuity formula. The growing annuity formula would be PV 0 equals C1 over I minus G, or R minus G in the textbook. And then you have the growth factor on the top because the amounts are growing. Or in our case, the amounts are not growing, they're declining. So how are we going to account for that? That's the issue. And I think I put them all in one. Let's do that again. I say 1 plus G, that's the growth factor, and then the discount factor, and that's all to the power of T. So that is the formula I have to use, right? And for the cash flows that we have, it doesn't look exactly like the timeline on the formula sheet. The first one, C1, turns out to be 500 over 1.01. And then the next one, remember for the formula, everything has to be, they have to be level cash flows with a growth rate, right? So it's supposed to be like C1 is the same. And the next one should be C1 1 plus G. That's the formula sheet. And then let me see. So C2 should be C1 times 1 plus G. And then the next one should be C1 1 plus G squared. But we don't have that. We have 500 divided by 1.01. We have then 500 divided by 1.01 squared. And then the next one is 500 over 1.01 cubed. So I have to try and I have to force this to look like this. So I can do that. I can do that because C1 is this one here. And I see that over here. However, there's an extra term. The extra term, so just writing it out. So C2 for me, the new C2 is going to be 500 divided by 1.01. And then that leaves a 1.01. Right? Is that not the same as the other one that I checked? I just moved it over. It's a fraction, right? I move it over. So that means I'm going to do it in green. So this is C1 in green, and this is C1, so that's right. Those are all C1. And that means 1 plus G must be the rest. So I asked you to solve that. I asked you to solve 1 plus G equals 1 over 1 plus 1 over 1.01. Solve for G. So I'm trying to force what I've got into the format that I need for the formula. So solving that, the two items I made blue, or I squared off in blue, you're going to solve that. That's what I did here, but it looks a little more confusing, I think. All right, so let's take those blue, let's take those. So 1 plus G must be 1 over 1 plus pi, I said. So what we're trying to find is the growth rate, which we know is negative because the amounts are declining. They're not growing. So solving, in this case, then G must be 1 over 1.01 minus 1. And when you solve this, what do you get? Right, and a little bit more. Right, Tiana, it's a long thing. So it looks like it's negative 0.009. So when you get up to there, it looks like negative 0.01. It's almost like that. That's what the swirly, the tilde equal sign is. So it's like a negative 1%, but it's not exactly negative 1%. All right, so it's important to notice that it's not negative 1% exactly. It's a little bit smaller. Okay, so it's not, to be precise, to get exactly the same answer using the real rate and real amounts, you have to use the precise result. So it continues 0, 0, 9. Oh, I forgot the 9. Let me go back. And then 0, 0, 9, 9, 0, 0, something like that, right? And then your calculator rounds it off, but it keeps going. Okay, it just keeps on going like that. So you're going to store this in your calculator. And your calculator will store up to 25 decimal places, I think. I understand. And now that you use that, you put that into this formula. It's very sensitive. No, I can't write it. I'm trying to write not exact. I'm going to write it here. It's not exactly -1%. So what you're going to do is put that in this formula. So in a test situation, you write that formula with all the numbers. So let's write the numbers in that formula. The first one is the C1. G is really long, so we can just use the symbol G as long as we're clear that this is G. Okay, so we would write PV is equal to 500 over 1.01, or you could just figure that out on your calculator. So that's C1. And then I, which is the real discount rate, was given, right, as 5%. So you can put that in. That's not so hard to put in. So 0.05 and then minus G. Now you got to just be careful with the negatives there. And then 1 plus G on here, and then 1.05 on the bottom. And there are 5 of those. So this is what you would write on your test, where G was solved. G was expressed on the other page, but I could put it here, negative 0.00990099 dot dot dot, like that. Okay, so what you're going to do for this is always recall 1 on your calculator. And if you're still resisting using my calculator or using the calculator, remember, you have to get the exact decimal places I get. So you will lose marks if you don't have the precise decimal places. If that's an incentive for you to learn how to do this with the storage buttons. So then, entering this into your calculator, always start in here. And then work out to the outside. Work towards the outside. And what do you get? So you're going to say 1 plus recall 1 equals, and remember recall 1 is a negative, so it's going to be less than 1. Then you're going to say divide 1.05 equals, then you're going to use y to the x and put the power 5 and say equals. Then you're going to change the sign to a negative. Then you're going to add 1 equals, and so you will have all of this done. And you can multiply with a bracket if, yeah, I think so. 500 divided by 1.01 equals, and then divided by bracket 0.05 minus, don't forget the minus, recall 1, and I'm out of space, recall 1, close bracket, equals. I think that should work. And your answer should be 2,103 and 32 cents. Exactly. Let me know when you've got it. Did I get it? Great. Oh, okay, try again. And practice, okay? This is not easy at the start for some people. I had difficulty. I remember entering this into my calculator, and I found this method to be the best. Anybody else got it? I want 5 people to get it. Yeah, you got it wrong. Yeah, you would lose marks, even though you're close. So you did something wrong. No rounding. Don't round anything. You're going to get the wrong answer. Very good. Try again. I have got 2 people that got it. I want 3 more, at least. So I will send you that solution. I'll send it now. I don't have the timeline and all, how you punch it in. Great, Ivana. So you can refer to these videos, but I can send you the solution set. someone's calling me. Turn that off. I'm gonna send you that document. What is going on? So you should print all this stuff out, in my opinion, or just keep them in organized digital files. There you go. All right. Good. Okay, I have 1, 2, 3, 4 people got it. One more. No lying. I'll know. Okay, so we got 5 people got it. All right. So others who haven't, just put that aside and we'll work on that. Or you'll practice that. And if you have questions, let me know. What I want to do next is go back to the notes. And I'm talking about the original notes. I'm talking about the lecture notes. Why is it not opening stuff? I don't know. Okay. Okay, so these notes. And I want to go all the way to the end. Yeah, I did call it the pension problem. So we did all of this. So I'm all the way on to page 81. So this is an annuity problem. 2 annuities, though, that you're going to deal with. You should follow the prontuario, and it tells you what chapters we cover. Okay, so this is the material on time value of money. Just going to double check. So this weekend I'm going to put up problems from the textbook so you'll be more tapped in with the textbook. You should all have the Connect account and the digital textbook at least. Not sure why my files are acting funny. Things are not opening. Oh, it's just slow. So you can, I'll put assignment for chapters 1, 2, 3, and 4, and you'll see that you can solve those problems or answer those questions. Okay, because this is time value of money, this overlaps. It's all over the book really, but chapter 2 is time value of money. Okay, so the pension problem. You're going to pay $3,000 per year for 30 years into a fund earning 12% per year. The first payment is in 1 year. So you see that this is represented by the timeline at the bottom. So it starts here, one period from today, you get the 3,000, and then every year until the 30th year. So this is an annuity, and the annuity formula can be used for that. It will grow to an amount, and then at the end of the 30th year, 20 payments will be received starting one period or 1 year later, and that will continue for 50 years. So the question is, how big can these find the future value of the annuity? Remember, every single point in time, every amount is both the future value of the payments before, or can be seen as the present value of something to come. It's not just $3,000 that you have at year 30. You've accumulated an amount, and that lump sum is the future value. All right, so once we get that future value lump sum amount, we can figure out the next annuity. We'll treat it like it's the present value of the future payments and solve for the payment size. So it's two annuities. The first one we need the future value of. We use that as the present value for the second annuity. So that's the approach that I have outlined here. So the cash flows going in, I can use the annuity formula to get the present value, but then I really need this. So this says if you put $3,000 away a year at that interest rate of 12%, So where could you get 12%? 12% is really high. Right now, banks' interest rates are very low. So it's probably not in the bank that you're going to get 12%. But there's investment opportunities that over time can yield on average about 11%. And that's why people talk about the stock market, because over time, historically, if you leave your money in the stock market, even though it goes up and down, on average, the return is about 11.5%. So I'm just rounding it up to 12. All right, you're not supposed to touch it. You're supposed to just leave it there and let it accumulate. And people play the stock market. They put money in, they take it out. They, some people benefit, some people lose. But if you just leave it there, historically, you're going to get that 12%. And look at this. If this happened, putting $3,000 away, starting tomorrow, if you did this, and you did that every year in the stock market, I'm not advising anything. I'm just saying at 12% over the last 100 years, you'd get about 12% if you left it there. So per year. So this, what looks like $24,000 in present value terms, actually accumulates to almost $1 million, $750,000, right? It's a lot of money. And that's what I have. So let's get that on our calculator in a second. First, I'm going to show you the next. So that's the first part. So I've divided it in parts. So this is like part 1, right? And then the second part is to figure out the payment size. So this is the second annuity where I treat this amount as the present value. And what I'm looking for this time is the payment for 20 years, again at 12%. Why at 12%? So I can just leave it there. Well, anyway, if someone was going to guarantee me 12% for my $1 million, I leave it in the fund and I get 12% out. So there's some assumptions here, right? That someone's going to consistently, or I'm going to be able to consistently get 12%, but just fine. This is how we're going to solve this. So then you're taking money out, or you're getting an annuity payment, which you can make arrangements for with a financial provider. You can buy an annuity, and then it'll pay you this amount over time, while the fund continues to accumulate 12%, even though you're drawing money out. So what can you get? What can you take out? So let's solve it with our calculators. Let's put all these numbers in. So for the first step, oh, did I say part 2? This is part 2, or step 2. So they're just 2 annuities. Don't get tired. Hopefully you don't get tired of, it's just the same formula again and again and again. In this case, just again and again. All right, so put these numbers in your calculator. 30 periods, interest rate is 12, nothing in PV because that's what we want to solve. The payments are out of your pocket, so they're negatives. And then ask for FV. So I'm going to even skip the PV part, right? I'm going to go right to the FV. I could calculate for PV, and that would have given me this amount here, 24,000 in PV terms. But the equivalent amount at 12% per year in future value terms is $723,998.05. So make sure you can get that, and we'll go to the next step, or part 2. Let me know if you've gotten it. And then store that amount. Very good. So it should be as a positive because you entered the payments as negative. Very good. Okay, a couple more people. Very good. Okay, so the reason why is on the timeline, right? Oh, this is a good question. And if you understand it, you're going to understand all this better. So what you figured out here, if you use the PV, that's the value here at time 0. The present value of all of those payments. However, remember time value of money, what is that worth over here at time 30? The future value at time 30 in the time value of money, what is it worth? I could have put that in an account earning 12% every year. So the future value is much bigger because it's the value of investing that at 12% every year. So that's why it's so big, because 12% is a big number. Okay, so it's $723,000. And I represent that in the formula. You see, that's accumulating that amount. So there's the payments. I've taken each payment and I've combined them. I've collapsed them into this amount, PV0. So that's as though, from the perspective of today, it would be worth $24,000. I would spend $24,000 and put it in an account, and it'll earn 12%. To become 723,000. Ariette, go ahead. I was just answering your question. Does that make sense? So what I'm saying is the FV, I'm going to put it here, is the 723,998, and that's FV 30. But then I treat it like it's the present value of what's to come, because I'm going to use the annuity formula with that as the PV. Remember, every point in time, every amount in time has two perspectives. You can see it as the future value of what accumulated, or you can see it as the present value of what you can withdraw. And that's what's reflected here. Basically, the question you're asking is the essence of the problem, to show you that we can look at it as a fund initially that we're putting into, and then one that we're withdrawing from. Why don't I did put PV30. It does say PV30. This is PV0 because it's at time 0. This is a different number. But see, FV30 is 723,000 and PV30 is 723,000. Okay, thank you. Thanks for the question. All right, so we got this. Store it. Now we're going to find out the payment. Look how big the payment is. If you did this, you could comfortably withdraw almost $100,000 a year. So that's why, and that's what people have counted on for the last 100 years for their pensions. However, even though this is not a pension class, I think there's a course in pensions right now that you guys could take. Pensions are in crisis because it's really hard to get that 12%. Anyway, there's lots of reasons for that. But in this case, in this storyline, it's a handsome withdrawal of $100,000. So how do I figure it out? Let's put in the values for the annuity where we have deposited an amount. So you can put this into an annuity. You purchase the annuity, and the amount will stay there, and you withdraw 20 periods at 12%. You put the PV in there, right? So you recall one. The payment is what we want. We're not interested in future value right now. So compute payment, and there you see your $100,000. It'll come out as a negative on your calculator because you put a positive in here. If you make it a negative, if you make this a negative, then you'll get a positive at the end. It's up to you. Yes, Juan, at 12%. So you can think of it as payments, Juan, or everybody, not just Juan, Juan's pointing it out. You can see it as payments of $3,000, or you could see it as a lump sum of $24,000. Those are the same thing. Okay, so you can see this drawing. You could see it as, actually, maybe I'll draw it again. No, I don't have much room, do I? You could see it as, no, I'm not going to be able to draw it well here. So you can think of it as, I'm going to use K for thousands. So 3,000, 3,000. For 30 years. You can see it like that, or you can see it as this amount that we figured out, the PV0. They're the same thing, right? I said equals. $24,000, how much is it? $24,165.55. Okay, so that timeline is that amount. So now that it's a lump sum, I can move it around and ignore those payments in between. Right, Brian. It's not very real. It's not very realistic. You're going to find 12%. That's true. That was the good old days. Whenever people talk about the boomers, the baby boomers, they enjoyed 12%. But I don't know where we're going to get 12% in an annuity these days. Yeah, you're not going to get 12%. So, but still, let's figure it out. Okay, give me the answer for 6%. Let's look. So the highest one Juan says that he's seen is 6%. So let's do the same thing. Use 6% though. So take that money that you've accumulated and put it in an annuity. Or let's say there's a pension fund, right? The pension fund, when you withdraw, it goes down. The interest rate goes down, let's say. If you use 6%, what would be your all you have to do is change this to 6. Tell me, what is your payment size? How does it change the answer? Some people are still trying to get the 96,000, I think. So let's get this. It's still pretty high, even if you get 6%. Right. Yeah, so it's low, but still 63,000, that's a salary. That's not bad at all. The thing that you have to consider when you think about pensions is you don't know the future, and there might be inflation. I haven't even mentioned inflation in this example. So sometimes pension payments, not sometimes, in fact, pensions are adjusted for inflation. So you're going to get a little bit more, but that wasn't introduced in this problem. I'll give you other problems like that. Okay. Okay, so you see the sensitivity to the interest rate. So pensions have been very popular because they provide some guarantee for old age, right? It's an insurance. It's an insurance against living. It's insurance against living, protecting you from being alive. That you have these expenses, but you can't work, or you're too old to work, or you're not well to work. And the idea of pension have been pay-as-you-go pensions, usually where the current working population pays for the pension fund for those people who have already retired. And that's a problem when you have a slowing or a diminishing population. So when the working population is less than it had been in the past, and you have so many people retired, it creates a problem. Oh my gosh, that's Juan is asking me about the future for PR. Of course, you have to rethink things. There's a future for anything. You got to be creative. I moved here, Juan, but I appreciate the question. I did move here, and I am hopeful for PR. We have to think differently about things. We have an abundance of resources. I read a report yesterday about water and agriculture in Puerto Rico and all the potentials. I mean, there's always trade-offs, right? There's always this is the best quote I've heard of late, and I keep on repeating it, so people are kind of getting tired of me, but I'll just tell you guys once. There are no solutions, only trade-offs. And that was said by Thomas Sowell, great economist. And that's even an economist talks like that. Talk about trade-offs, right? So in Puerto Rico, you got to trade things off. You got to think. People have to think differently, is basically what I'm saying, and realize that there's sacrifices to be made, and there's benefits to be had. It's just a matter of this generation having to make those sacrifices. But watching, well, I've seen students leave the island and I've seen students come back, and that gives me a lot of hope because they see potential here. One's asking about other things. Okay, I don't want to go way off topic, but basically, I just mentioned the natural resources here and what we could do with them. We need to be smart. We need to see opportunities. The most important thing is to think differently. If we keep on thinking the same way that we have, or if we continue with this line of thinking, that's someone's going to bail us out, or we have to wait for someone to save us, that's just the wrong mindset. That's the wrong mindset. Some people leaving and a lot of people coming. So think about what those people who are coming, think about how they see things. Ask them how they see things. I guess that's why you're asking me and why I'm here. But there's definitely opportunity. The greatest resource are the people here and their attitude. So you got to have a good, positive attitude, which I see more people having here than in other places. Maybe not a positive attitude about the government. People are very negative about the government. But there's a lot of things you can do aside. Again, don't wait for somebody, Juan. Make it happen. You don't need a leader. You just need people to take initiative. I really don't think waiting for leader, waiting for federal funds, waiting, I don't think that's the solution. I think it's doing. We've got brilliant people here. You have engineers. You have excellent doctors here. There's things that can be done, but the government's caused a lot of problems. And that's the trade-off. When you wait for somebody, those people can cause problems. All right, so I shouldn't be talking off topic too much. I digress. Not just with the pandemic, we need a reality check with everything. In the last 5 years, there was the water shortage, there was the blackout, then there was the strike because of the economic default. The default on payment to our debt holders. Then there was the earthquake, and then there was the huge hurricane. You've seen it all. And now the pandemic. Pandemic is like old hat. We've been doing this for 5 years, it seems. So we really need to see the advantages and not borrow problems from beyond our shores. We need to address the problems we have here and see the assets that we have here. We have great assets. Maybe I can share that article. Maybe I'll share that report with you. I don't know. You don't have to read it, but I'll share it with you on water management and agriculture in Puerto Rico. It's kind of long, but it was an easy read. It was English. It was in English, so it was easy for me. But I see great opportunity. We need to plant trees, and we need to harvest and clean our water. And restore the water, or get people capturing water out of the rain. So once you got water, then you have agriculture because you can get irrigation, and then we become somewhat more self-sufficient and not dependent on shipments from abroad. Urban farms. Anyway, this is what I think about. I think about the most important thing, and it's food security. It's the most important thing, but food security depends on water. So that's why I'm thinking about water and the incredible resource of water we have here. All right. So, right one. Okay, so back to work. Thank you for the questions, and we can talk about that more later. All right, so let's see. So that's where I left off with that. So everybody's got that? I haven't heard. If you guys can make all those calculations, let me know. So that's the pension problems. Cash inflow to the fund and then withdrawal from the fund. And the payment amounts are handsome depending on how much you deposit. So the advantage all you guys have is time. Make the most of the time you have. That's the greatest advantage you have against people like me, people older than you. So use your time wisely. Make the time value of money work for you. I'm not sure, Von Mighty, what you mean. It doesn't consider the reality in the reduction of payments. The calculations? Everything is accounted for with this problem. The annuities keep track of the reduction of the fund as time goes by. It's quite fascinating, very simple formula, but it does take care of the amortization. Anyway, we're going to talk more about amortization of loans in a bit. Okay, everybody's got these answers? So you're going to, in this problem, you're going to withdraw $96,000 for 20 years, and then the fund is done. That's it. As you withdraw the payment, the remaining amount continues to accumulate at 12% in that exercise. So it does account for the withdrawals. So we'll see that in some of the notes that I gave you. All right, so the last couple things about these notes, I just make some points here about the difference between counting periods of interest and periods of number of payments. Just to make you aware, if you get a problem that tests you, oh, you're just talking about the payment, so what's going on in Puerto Rico and the pensions. Yeah, or in pensions in general. Well, that's not considered in my problem. I'm just saying that they stay the same. But yeah, in reality, pensions and pension, well, it depends which pension you're talking about. But in this problem, no, you're getting the same amount. And in fact, in some pensions, pensions are indexed for inflation. But yeah, what's happening in Puerto Rico and different pensions, you know, I need to know which one you're talking about, but anyway. In this case, you're getting the same amount. Okay, so how many periods of interest between end of period 18 and end of period 55? So you could count, but there's probably a faster way. So how many periods of interest between the end of period 18 and the end of period 55? If you're talking about Puerto Rico and the police department and the government payment pensions, I don't know all the details, so I'm not going to comment. But yeah, it's possible that happened. If the money's not there, so it's a real concern. Pensions are at risk worldwide, not just in Puerto Rico. Okay. So how many periods of interest between 18 and 55? How do we figure that out? If I said, if you think about periods of interest, interest occurs within the interval, right? Within these intervals, interest occurs, or even growth occurs, right? So to figure it out, is it 55 minus 18? If you take 55 minus 18, what do you get? You guys can't see the bottom, I made it too big. So if you did 55 minus 18, yeah, that worked. You would get 37. Is that the way to do this? I suggest look at your fingers. If you look at your fingers, okay, I'm going to draw a really bad hand. Okay, so this is your hand, right? And if you were to number these, 1, 2, 3, 4, 4, 5. And what interest is, it's between the fingers, right? It would be the between, in between. How many gaps in between your fingers? Gaps would represent like the growth or the interest rate occurring between them. So that's how you would figure that out, right? So the big one minus the last one, that gives you 5 minus 1 gives you 4 gaps, correct? So that's how you do this for growth rates, interest rates, or even inflation. You guys can't see that. I gotta make this smaller again. Okay, so that's what you're doing. So remembering your fingers, if you want the periods of interest or the periods of growth or inflation, it's going to be the gaps in between. So it's just the 55 minus 18. So that's pretty straightforward. That's different from counting. So this is here. I just put a formula here. So you can put this formula on your formula sheet. You can say this is a formula. You can say number of intervals is equal to the end of the last period minus the end of the first period. So you're just you're minusing 55 by 18. Or you could do this for the beginning as well. As long as you go from beginning to beginning, you'll get the right answer. Now there might be questions like this. So just pointing out, if you want intervals, it's 5 minus 1 for your fingers, or last minus first for a timeline. But what about payments? What if you want the number of payments between 18 and 55? So payments are denoted by these tick marks here. So this is a payment. So that's different, right? So notice you should have realized that if you take 55 minus 18, you're going to be off by 1. Again, look at your fingers. You want to count fingers. So for counting fingers, if you take five minus 1, what's going on with my image there. If you take 5 minus 1, you're going to come up short because there's 5 fingers, not 4 fingers. So what you need to do is add back 1. And that's the rule for figuring out the number of payments between 2. The rule is last minus first plus 1, okay, if you want the number of payments. So you can put that on your formula sheet as well. Or from the beginning of period, beginning of last minus the beginning of first plus 1. And that will give you the number of payments. Okay, so just a trick, a tip, if you need to do that. You have to add back that finger. Add back the one you took off. Okay, so you have with you on your hand a way of remembering the difference between periods of growth, inflation, or interest, and payments, where the payments would be each finger. So for this problem, there should be 38 payments. However, there's 37 intervals. How's that? And then we turn to interest rate conversion. So I gave you lots of documents on that, and I hope you got started. But I'm going to go through it with you. Any questions about this? Number of intervals formula and number of payments. Those are the two formulas I'm adding. And remembering intervals could be growth, inflation, interest. All right, let me pull up the interest rate conversions. All right, let's start here. So this is what we left off talking about. And now today, I mean, I left you with the notes, but I will go through what I've done here. So I gave names. I'm going to use notation to distinguish between the different rates. So some students got a little bit confused or were asking me, where does real and nominal come into this? So I'm going to tell you right now, unless I tell you, and I told you at the end of last class, unless I specify that dollar amounts or rates are real, you assume everything is nominal. Okay, so everything is nominal. If I want you to work with real rates or I tell you something's real, then you'll deal with that. Okay, so these are so this is the rate that I told you was the annual periodic rate. And I'm going to give it a special notation. Does this need to be bigger? Make it a little bit bigger. So the special notation I'm going to give it is, I'm going to use an R, and I'm going to put a subscript on these rates. So these are going to be known as stated rates. And unfortunately, sometimes you'll see in my notes and in some places, I'm going to use the typewriter. Sometimes they'll refer to it as nominal, but that doesn't imply the other one is real. So this is the stated rate. Okay, or what did we talk about last time in the other classes? This just reflects the simple interest. Paid over the year. Okay. So you put an R, and because it's over the year, I have to specify one from another. The subscript will be in fractions of a year. So the daily rate, which this one is 1 out of 365. We're not going to worry about leap years and all that. Just 1 out of 365. So that tells you that's a fraction of a year over which the compounding takes place. But how it's calculated, R1365 is calculated by taking, and you know this already, I'm just repeating, by taking the effective rate, what you really pay every day, what they really charge you every day on your outstanding balance. Oh my goodness, this is so sensitive. EPR, my iPad should be here next week. Everything's going to change with my demonstrations here. All right, so that's taking the effective period rate and spreading it out over the course of the year by multiplication. That's what the stated rate is. So from here, it's just a simple interest. From here, I can generalize that and create a formula, which I'm going to talk about. Is everybody okay with this notation? So this is the effective one. This is the one you use in your formula. This is the effective rate. Our formulas only take effective rates, our time value of money formulas. And It's called the effective period rate. Any questions? So that's the rate you pay on every dollar outstanding. If a balance accumulates, it's going to accumulate every day at that rate. If you ignore interest paid on interest, you just do it this way. But nobody does that. Just they're allowed to state it that way in financial institutions are allowed to give you what's called the APR, the simple interest representation. So different products or different types of different kinds of financial, I don't call them financial tools or financial products, have different types of rates. So I outlined some examples and we're going to focus on these. I'm not going to get more complicated than the ones I presented here, so learn these well, okay? Let me see if you have any questions. Nope, comments. Everybody's good so far? So that's my notation. I'm going to use the R for the simple interest rates, and I'm going to use EPR for the effective ones. So before you solve a problem using the time value of money formulas, you have to have an effective rate. Okay, so what do I have here? So, some notation. So N is a subscript that I'm putting on R. So R, like subscript N. N is the length of the compounding interval in a year. So out of a year, a day is 1 over 365. Note 1 over N is the inverted N. And it could be interpreted as the number of compounding periods per year. So if N was 1 over 365 to represent a daily rate, then there's 365 periods of compounding in a year. I'll just see like that. Okay, so credit cards are stated, the APR on your credit card will be stated as a stated daily rate with the notation R1365. And a way that could be said is annual rate compounded daily. Okay, so if you have a problem or if you're reading about rates at any point, that's how it might be termed. And how you're going to know it's a stated rate is it's going to say annual rate, but the compounding frequency will be different from a year. When those are different, you know you have a stated rate. Okay, when they're different. So that's for credit cards. What about mortgage rates? In the US, mortgage rates are R112s. They're stated monthly rates. That is, they're annual rates, but they compound monthly. Those are different, you see? That's how you know it's a stated rate. Whereas EPR 112, how would we say that? How would you refer to that? I'm going to use a typewriter again. So EPR 112 is the monthly rate compounded monthly. Notice that those are the same. Okay. That's different than this amount, R112. 12 times EPR 112 is equal to R112. Some of you, this is boring because you get this. Others, I just got to provide this instruction. And hopefully with some review, you're going to understand this. No problem. You should know this. This is a review, actually, of what you should have learned. Remember, this subscript here is just a notation. You don't multiply that, okay? So what you have to do is take your effective monthly rate and multiply by 12 to get the simple interest that is stated on a mortgage, on a loan statement. Okay, so when you buy a property or you take out a loan to buy that property, it's called a mortgage, and it will probably have the annual rate compounded monthly as the APR. You need to work with that in formula, in amortization. You need to convert it to the effective monthly rate. How do you convert from here to get the effective monthly rate? You would have to take the rate they give you and divide by 12. Okay? Do the opposite. Okay, there are other rates. So we have so far the daily rate that you would take it if someone gave it to you on your credit card and divide by 365. On the mortgage, you would take this rate they give you and divide by 12 to know the effective monthly rate. There's some other kinds of rates that you should be comfortable with. One is the quarterly rate. Notice the annual rate compounded quarterly. These are different. This is quarter. This is annual. That's how you know it's R 1 quarter. It's a stated rate. If you want the effective annual rate, EPR, I have to start over. EPR 1 quarter is just taking the stated rate that you're given and dividing by 4. So what's an example of a situation where you'll hear about a quarterly rate is with dividend payments to stockholders. So in this application, when you learn about stock, we did some problems with stocks. I mentioned that rates or payments, dividend payments were either annual, or I did say, I don't know if the example I gave you quarterly. So you would need the effective quarterly rate, and the way you get that is to convert. They might give you in a problem, or in reality, you might be aware what the effective quarterly rate is, but if you're not, you would have to make this division. The other kind of rate is the rate on bonds. For bonds, the rate is a stated semi-annual rate. So it's the annual rate compounded semi-annually. These are different, semi-annual and annual. Because those are different, we know it's a stated rate. And because it's compounding semi-annually, it's half of a year. So the notation is R112. Can you see that? Is that big enough? You should have the document in front of you. I will make it bigger. Okay, and this also coupon rates on coupon bonds and yield to maturity on bonds are stated semi-annual rates. So those are the 4 that are the most, the ones that I'm going to use in this class, but you should be able to convert with all kinds of rates. Actually, there's going to be some more. I'm going to talk about the continuously compounded rate as well, and I think I have a few other examples. But you should be able to use this formula to go from stated to effective rates. If you have a stated rate, you divide to get the effective rate. If you have the effective rate and you need the stated rate, let's say in a bond problem and I want you to give me the yield to maturity as a stated rate, then you would have to multiply the effective rate by the number of compounding periods. So all I do here is I go through the terminology for the effective rates. So we would call this, like I said, EPR 1365 is the daily rate compounded daily. Notice these are the same here. That's how you know it's an effective rate. The monthly rate compounded monthly, that's how you know it's an effective rate, because it's monthly rate compounded monthly. Okay, so the statement over which the rate is being made, the stated period is the same as the compounding period, so those match. For the quarterly effective rate, it's the quarterly rate compounded quarterly, and for the effective semi-annual rate, it's the semi-annual rate compounded semi-annually. Okay, so I've just spent 2 pages going over these to introduce this general formula. This is converting between effective and stated rates. Now, let's pull up this document. No, not this document. Applications, no, map. Okay, so interest rate conversion map. So now I'll show you the two formulas that you need to do all this stuff. So there are two formula. The one we just discussed to convert between effective and stated rates and vice versa. So that's what I just spent the last 20 minutes talking about. And then there is converting between effective rates. Let's say you have a rate, but what you really need to solve a problem, because payments are being made monthly and you've been given the effective annual rate, you need to get the effective monthly rate. So how do you figure that out? So what I did was give you a string of equalities between rates. I've related all the rates to each other, connecting them to the annual effective rate. So EAR is the effective annual rate. You could also think of it as, now if you don't like all my notations, that's fine. If it doesn't do anything for you and you have another way of solving these, that's fine. I'm not going to require you to solve them like this, but you need to make your conversions properly. And this is, I think, helps. So EPR 1 is the same as EAR, right? So that's the annual rate compounded annually. So what have I done here? Well, we understand compounding. We understand that compounding in factors is fine. 2 factors of the semi-annual rate make 1 year. 4 factors of accumulating the quarterly rate make 1 year. 12 factors of accumulating the monthly rate make 1 year. And 365 factors of accumulating the daily rate make 1 year. So they have to all be equal because they all make 1 year. Any questions so far? So in the problem that we had with the credit card, I asked 2 questions. How much interest do you actually pay per day? To figure that out, you would use the first formula. You need to take the rate they give you and divide by 365 to get the daily effective rate. So we did discuss that. The next question is, how much interest do you actually pay per year? So the first one was about the day that you actually pay. But to figure it out over the year, you have to compound. So this is the basic time value of money formula, right? This is even if you don't see it, this is 1 plus I to the power of t, where PV is treated as like for every dollar. So you always imagine like a 1 here. It's for every dollar. And that gives you FV. And you can't see that. I'm going to okay, so you imagine a 1 in front. That's 1 plus I to the power of t equals FV, which would be the amount, the principal amount, the $1, plus the interest in effective terms. So it's basically using the time value of money approach, but with the rates alone. So if I want to figure out the effective annual rate, all I have to do is minus 1 to get the rate per dollar. And we figured out at the end of last class that was very different. You would compare that to the 18.4% APR and say, I really pay $20.20% on every dollar outstanding, not 18.4. 18.4 just reflects the simple interest. Any questions so far? All right. So this idea of equivalent rates is really important. I mean, they're both important concepts. Well, unless you have questions, I'm not going to say anymore because maybe you understand it. Okay, so if you have questions, I'll add more, but if you don't have any questions, I'll leave it there for now. And let's go into the next document, which is the applications. And I did give you solutions for that. So you should have taken time to work through that material. Okay, let's get this document. Okay, this document, the summary document. So here I outline the steps for every problem in time value of money. Read the problem and find the timing of payments. That's your first step. The timing of payments, if there are payments. If there's no payments, then it's just a basic time value of money problem. So identify the timing of payments and convert all rates to an effective rate that compounds with the same frequency as the payment frequency. So if you have a problem about credit cards, you need the effective daily rate. If you have any other information about rates, growth rates, you have to convert them to effective daily rates. Then you make your timeline and you apply the formula by focusing on the portion of the problem that uses the formula as is. Okay, so that's what we're going to do. And then you adjust. In the last step, you modify the formula to move lump sums to desired positions. So if you have an annuity that you solve at some different point in time and you need it today, you need the value today because you need to know the price or what it's worth to invest in some opportunity that leads to those future cash flows, then you need to discount everything back to time zero. Or if you want to know the future value of something, you have to accumulate it to whatever time period you want. Okay, so these are the steps. The most important thing is this one. Everything else that you're used to, I think. So identify timing of payments when you read problems, if there are payments. So let's look here. We have the problem of coupon bond. Bonds often pay every 6 months, so they are stated as annual interest compounded semi-annually. Example, consider a corporate bond paying semi-annual coupons at a rate, 1 minute, a rate of 6% with a face value of 1,000. So you see how it says this? Annual rate of 6% with a face value of 1,000 maturing in 8 years. So you're told that the yield to maturity is 7% per year compounded semi-annually. See how those are different? Year and semi-annual, that's how you know this is a stated rate. So what do you do with the stated rate? You convert it automatically to effective periodic rate. Convert it to this effective semi-annual rate by dividing 7% dividing 7% by 2. Okay, automatically. And that will give you the effective rate semi-annually. The other rate you need to divide by 2 is this one, because this is the coupon rate. That also has to be divided by 2. So that's what we do below. I divide the coupon rate by 2 and times by 1,000, right? It's still the same rule to figure out the payment. The face value is 1,000, and there's, because it's 6 years, but I need to convert, I have to convert the periods also to semi-annual periods. That's how I get 12. I'm 16, sorry. Not 6, it's 8. Sorry. 8 times 2. All right, and then once we've converted everything, we write our formula out, and this is the one that's going to get you the points on the test. And entering everything into our calculators in order, n is 16. Interest is going to be 3.5. And, oh no, it's just y, right? And then PV is what we want, so I'm not going to put the price down. And I just put in the payments that are 30. And then 0 into FV, because that's not what I'm interested in. No, sorry, 1,000 into FV, because this is a coupon bond. Everything is positive because those are the future cash flows that I'll be receiving. And we figure out from that the price is $939.53. So that's the fair price. That's the most you'd be willing to pay to get these things later. The $30 every 6 months, and then the $1,000 at the end. Questions? So I don't have any new formulas for you. It's just using the original formula. And then these 2 extra formulas on conversions. So, any questions? No questions? Okay. Let's try the next one. Consider a bond paying semi-annual coupons at an annual rate of 12% with a face value of 1,000, maturing 25 years. The bond, okay, so now the market value is 1,000. So these bonds are selling in the market for $1,000 right now. So that's what people are willing to pay for it. So these aren't an initial purchase, right? These are traded. We're going to figure out at that price, what is the yield to maturity on that bond, so we can compare it to other bonds, other bond yields. So let's get all of the elements. You're told that they're 12% coupons, but this is the annual rate, right? So those are stated rates. So what you do is you have to divide that by 2 and multiply by 1,000 to get the $60. The future value is 1,000. It's 25 years times 2, so you have to convert everything to semi-annual periods. And when you punch this into your calculator, it's going to be 50 into N. Interest is what you want, so you're not going to put it. 60 into payment. Wait, I'm going to put the price first, right? Because that's left to right. So PV is, I got to go back. 1,057.98. What did I do wrong? 1,057. Okay, I gotta do that again. And put that into the PV. And you put it in as a negative because that's what you'd have to spend for it. That's a cash outflow. and then you tell it the payments are going to be received of $60. So those are positives, and that's the payment. And the other thing to be received is the face value at the end, which is 1,000. And then you ask, if you do this right, you ask for the yield to maturity, or I. You will not be able to do this without the calculator. What do you get? All right, yes, keep all the decimal places for sure, because we're not finished, right? We're not done. That's not the final answer. That's just the effective. So this is the formula that's going to give you, so this is how I expect you to write it on the test. And this will give you the effective semi-annual rate. But we're not finished. We need the yield to maturity per year compounded semi-annually. We need the stated rate. Remembering that this is how we got, or we could calculate the effective rate, we have to do the opposite and multiply the result by 2 to get the stated rate. So that is the final answer. Do not round any of your decimals. Any questions? In the second problem, or the last problem with bonds, I'm going to ask you to find the years. So you have information here on the annual rate, and you know from now on, right, that coupons are stated semi-annual rates. So that's the annual rate. You need to divide that by 2 to get the coupon by multiplying by 1,000. And then this one also, which is the yield to maturity, well, that's like your interest, your implicit rate of return, your interest rate is 6.6%. That also needs to be divided by 2. So you see, currently people are trading, they're offering $1,000 for this, $1,026.82 for this bond. The coupon rate is 7%, and the yield to maturity is 6.6. We need to convert everything into effective semi-annual rates to find the time in semi-annual periods. So we do all of this and solve for the semi-annual periods. Here's the formula. This is what you would write on your formula, on your exam. Entering in to your calculator, n is left blank. Interest is 3.3%. This is the price as a negative. The payments are $35 and the face value is 1,000. Those are positives. And ask for n, which is really t in our formula. Are we finished once we get that answer? Make sure you can get that, and then I'll continue. Let me know if you got it. Okay, so you got this amount, 17.9980647, which is fine because, those are just, it's not exactly 18 semi-annual periods, it's a little bit short, so it's just in days it would give you. But you want to take that and divide it by 2 to convert it to years. So it's almost 9 years. We'll just round it off for the answer. Follow the directions anyway. If there's ever a test with that question like that, follow the directions. If you're allowed to round, in this case it rounds up to 9. Okay, so you have to ask yourself after you solved a problem, am I finished? Did I answer the question? Go back and read the question in years. So you have to convert it from semi-annual periods to years. Semi-annual periods are smaller, so you divide by 2. You group them into years by dividing by 2. All right, let's continue, unless you have questions, and move into mortgages. No questions? This is, I said, it's a review, but you should be getting 100% on this, okay? So if you're not, let me know and let's figure out what you're doing wrong. Okay, so a mortgage is an example of an amortized loan where the principal is paid over time, not at the end of the loan period. Banks often quote mortgages as annual interest compounded monthly. So those are different. It's a stated rate. The terms of the mortgage are usually renegotiated during the term of the mortgage. That sounds funny now that I look at that. The terms, like the contract, the agreement, can be renegotiated. For example, the interest of my 25-year mortgage will be renegotiated or negotiated 5 years after the initiation of my mortgage. So you can negotiate for more time with a higher interest rate or less time. How did I say that? More time. Well, it depends, right? You can have more time, higher interest rate, less time, lower interest rate. So these are different kinds of things you can work out. So here's the example we're going to work with. $100,000, 25-year mortgage. And the rate is 7.4% per year compounded monthly. So this is a stated rate. I know that because it says per year compounded monthly. Those are different. And that means it's stated. So what I have to do is take that number and divide by 12 right off the bat. Divide by 12, and there it is. That's the rate I'm going to use. So put this in storage either as a decimal or multiply it by 100 and then put it in storage. You decide. I can't remember what I did in this example. So you decide if you're going to multiply by 100 or not. You just have to remember what you did, so write it on your paper. Because the TVM keys use the percentage value, right? So the first question is, what's the monthly payment on the mortgage? So it's just an annuity. The loan is $100,000. Some students confused where to put that, but that's the loan amount. That's the PV. And then this is the interest rate. You can just write I there. You don't have to write it all out. You've stored it with all the decimal places. It's going to be 12 times 25 years. So it's total of 300 months. Which is important for the formula because we're converting everything to months, the rates and the intervals. Okay, so that's 300. I multiplied my amount by 100. I put it into the interest. I put 100,000 into PV, 0 into FV, and then I asked to compute the payment. So I have to pay for this loan, I have to agree to pay $732.50. So let's see if you guys got that. Anybody get it? Anybody else? Anyone else out there? And the last problem, yeah, let me know if I'm going too fast because I don't hear from you. I don't know what's happening. So in the last problem, yeah, if it was 8.01, you would round to 8. Yes. Yes, Harriet. Oops, I wrote your name wrong. Okay, so let me give you some time to punch this in. Make sure you get that. I think that the one thing you might do wrong here is this whole multiplying by 100 thing. So be aware what you're doing because it's going to be a small number, right? These are the monthly rate will be a fraction of the annual rate, so small. And if you put it in decimals, it looks really small. So try not to get confused. Okay, anybody else? Anybody else got it? Nobody else? Anybody else got it? Anybody else there? Any questions? Okay, so I'm going to continue. All right, so the next question is, how much of the first 3 mortgage payments goes towards principal and interest? Okay, so this is really important to understand amortization. I suggest you put the headings of this table on your formula sheet. Okay? It's sort of cheating, but just so you have it in one place, or I mean, just remember where this is in your notes. Put all the headings here. I shouldn't put stars. I mean, the whole thing on your formula sheet, because it helps you remember how to do this. So first you begin with the principal outstanding at the beginning of the loan. Then you compute the interest. The interest is charged on the full amount, but which interest? The monthly rate is charged for the first month on the entire amount. Okay? That's different from the monthly payment, which you already figured out, $732.50. So that goes here. And to figure out, so if you figure out the interest charge, if you make this calculation, this is with your stored value, right? As a decimal, you'll figure this out as $616.67. So it has to be presented in payable amounts. So it's 67 cents. So we round it. Now have a look at this. If you haven't thought of this before or hasn't been pointed out to you before, this is your monthly payment. But this is how much interest. So in the beginning of a loan, amortized loan, you pay a lot more interest than you do achieve paying down the principal. It's a lot. Do you agree? So let's figure out the principal reduction with the monthly payment. So you'll take C and you minus off the interest. So that's all that's left. I mean, that's all, the amount that's left remaining is all that you've paid your principal down. So you've paid it down, when you calculate this, $115. That's it. It all went to, your payment went to interest. Everybody okay so far? And finally, let's subtract that from the principal amount and compute the remaining balance, outstanding balance. So this is what I've done in this table. You could do this in Excel. You could set up the formulas, and I have here the first 3. And obviously this continues all the way till you go to 0. So what you see is this is always the same all the way down. But this, actually, let's not use that notation. These are always the same, right? All the way. But these ones diminish. They go a little bit smaller and smaller and smaller as the loan goes on, because the principal is going down, or the balance is declining, so too will your interest payment. You pay the most interest at the beginning. Also, because of that, the reduction amount goes up over time, and so on. So that's the pattern. So you guys should be able to reproduce that, and you should be able to do it all the way down to 0. So you might have done this in accounting or other classes. There is the amortization table. When you have a loan from a bank, they'll give you this. They'll actually share it with you. So, lots of interest is paid at the outset. What is the total amount of interest to be paid? Is question 3. What's the total amount of interest paid over the 25-year period? How will we figure this out? Well, we made our payments all the same, right? So they're all going to be $732.50, and there's going to be 300 of them. So this is all we borrowed, 100,000. It turns out when you subtract the total payments by the amount loaned or borrowed, you are paying more interest than the original loan. So this is sometimes shocking for people, and I was thinking of giving you on your test a question about whether you should rent or buy, and obviously there's variables here that affect things. It'll have to do with your ability to pay, first of all. So if you assume you can make the payments, you'd have to think about what you're going to get in the end. Even though you've paid $100,000, more than $100,000 in interest payments, you own a property that was worth $100,000, but might have gone up in value. So you got to think about those variables when considering whether to buy. You also have to think about what's happening with interest rates. So if you have a property and then you want to buy, like let's say you want to buy a property later, you have to think about what are the interest rates going to be out in that point of time, and what do I have in terms of asset value at that point in time to be able to trade in what I've got and buy something else, or if I have to borrow more, what are the interest rates? So you have to know the patterns. You have to know you'd have to know interest rates and value at given points in time, today and in the future, to make these kinds of decisions. All right, so you observe the markets. A lot of people are watching right now because interest rates are very low. People are buying. Prices are going up on properties. However, I don't suspect that can last for very long. So in the meantime, you're paying a huge amount of interest, but you have a home and it's yours, and you can imagine if you're going to hold on to it for a while and you maintain it, you'll be able to sell it hopefully for at least $100,000. So without getting more deeply into mortgage and property values and the global financial crisis of 10 years ago, these are how you make these calculations, and these are the variables that you need to consider. The prevailing interest rate now versus the prevailing interest rates later, and the fact that you'll have a house now. What happens later, we're going to talk about that. We're going to talk about housing market a little bit later as well when we get into the next topic. Yeah. Okay, so stay tuned for that. And I think I'll put a question about rent or buy. Is it worth renting or buying? But again, it depends on these factors. Rent versus own. in Puerto Rico, there's a lot of incentive to buy versus rent. There are a lot of incentives. One, when you buy, your mortgage payments are tax deductible, so you realize tax savings, which can amount to a lot. Also, when you buy, if you buy a new property, you don't even pay property taxes for 5 years. That's another incentive. These are incentives that don't exist in Canada, where I'm from. And so people wondering why I move here. For the weather and for the incentives and the low taxes. So again, trade-offs. Have to consider it all. All right, so hopefully you learned something there. Let's see, the last question. The last question is about the refinancing. How are we going to do this? Assume the mortgage rate remains 7.4% for the remaining time of the mortgage. After you've paid 2/3 of your monthly payments, what is the amount still remaining to be paid on the mortgage? So 2/3 of 300 payments means right after your 200th payment. Okay, so I want to figure out what is the amount still remaining on the mortgage, so that way I can figure out or negotiate based on the balance and prevailing interest rates and my credit score what kind of interest rate I could get and what duration of the remaining loan I can negotiate. So there's 100 payments remaining. I don't expect you to be able to put these subscripts in, but I do expect you to be able to think through the fact that you're on the 200th period, 200th month, and the next month, 201, you're going to have to make a payment of $732.50. The interest rate stays the same. So even though in your calculator you have multiplied this by 100, you would have to write that amount or just put I, okay, if you don't want to risk writing the wrong number in there, because you will lose marks if you have the wrong number in there. So you could just put I. And then that's 100 payments remaining. So you could figure out with that information that what remains on the loan is $54,000. $54,549.84. You've paid less than half of the loan after 200 months. So you pay down a lot more towards the end of the loan. So interest payments, interest payments are tax deductible. Towards the end of the loan, you're paying, there's less interest being paid, you're paying down more of the balance. So those also would go down. Tax savings would go down over time, but the incentives are still there. So why does it say 201? Very good question. So let's say this is my loan. I'll start it here. So this is 0, right? It's month 0, month 1, month 200, and then month 201. So when you make your timelines, you can make a note that this is in months here. Okay, so you're going to make C1, C1, C1. So it's always the same. It's always 732.50. So I'm just going to write, well, I'll just put 7. I'll write C1. Now C200 is also the same as C1, isn't it? They're all the same, 732, but I should put the number on. So C200 is also 732.50, and C201, and so on all the way until 300. So all of these are the same, but I'm just putting the notation so you see. So all of these are already accounted for. I want to know at this point in time, PV 200, what remains. That's what I'm figuring out. So I don't even need to know about this stuff before. I want to know about these. And the first one is 1 period from now, like the formula summarizes. The formula figures out the present value of future cash flows beginning 1 period from now. Got it? So that's why this is C201. If we want to reduce the principal more with the payments, we just have to pay more, right? Right, Calvin, you start from there. Exactly, because the 200 is already taken care of. It went in, we already paid it. So we're at the end of the class. Let's see what I can tell you. So is there another question? No other question. All right, so I also gave you documents. What else did I give you? I gave you review documents, right? I gave you review documents, and I gave you, so these are problems to solve. And so 2.7, did I give you 2.8? I have to see what I gave you. All right, so I gave you 2.8. Okay, so I didn't give you the answers yet. So I just gave you up till 2.7. And then 2.8 with no answers, and 2.10 with no answers, and 2.12 with no answers. Okay, 2.14 with no answers. Okay, what I'm going to give you, I will give you the continuous compounding thing. Let's see. Let's look at that briefly. 212. Let's look at document 212 together. Document continuous compounding. This one. Before we go. We didn't even take a break. I'm so mean, hey? Sorry. So I expect you to look at these all by yourselves. I will send the solutions. I guess I'll send the solutions so you can fully work on this, and then I'll explain things properly, because maybe you understand things, you understand, not understand, you know how to get the answer, but you don't understand it. I want to talk about continuous compounding first. I'll send you all these solutions for you to study, and I'll also post assignment in Connect that will be due in 2 weeks. Also, you're going to have your test next. Let me see. Your test isolated for 26, I believe, right? So yeah, I can make an assignment due in 2 weeks and then the test on the 26th. We can still do that. So you're going to be working hard for the next 2 weeks to be really good at this material, but this is it. Like, you have all the material for the test, so devour it. Okay, I think did I give you prep questions? Let me double check. I gave you prep questions. Test prep. Yep, I did. Okay, so you have everything to study for the next 2 weeks. So at this point, if you really need extra help after you reviewed all of these next week, if you still need some help next week, so let's say this weekend, after this weekend, if you still need help, if you really need assistance, I will set up the TA to work with you, or I can work with you, okay? So let's do that. But you have everything at your fingertips. So let's look at continuously compounding, even though time is up and some of you have to go. If you have to go, go ahead and have a good weekend. Study hard till we see you next week. I'm just going to finish this discussion with the continuous compounding case. Probably 10 minutes. I really think it's important. There you go. That's document 212. All right. Okay, I need to backtrack. Let me see if you have questions first. And then I want to backtrack to the map. Calvin, you have a question about another exercise? Which exercise, Calvin? I'm going to send the solutions if that helps, and then you can ask me again. I really want you guys to exercise, practice. And this is like muscle training. You're going to be good by many repetitions. You're going to get better, stronger. Okay, Kelvin has maybe gone. All right, so let me pick up from here, from the map. Interest rate conversion equivalencies. Here they are. And notice as I'm going from here, so that's annual effective rate is, so one factor of the annual effective rate is equal to 2 factors of the semi-annual and 4 factors of the quarter and 12 factors of the monthly and 365 of the daily. What is the smallest? So I'm going smaller and smaller in my intervals. What's the smallest interval you can imagine? What is the smallest interval? So let's talk about the smallest interval. So let's say there's a rate So what I'm doing is taking the rate as a stated rate, like here, right? And over here, if it's a stated rate, I got the EPR by dividing the stated rate by the number of compounding periods, correct? So the stated daily rate was divided by 365. So similarly, I would, remembering if 1 out of 365 is the length of the compounding interval in years, then the number of compounding periods would be 365, right? Everybody with me who's here? So I want to make it smaller, even smaller. So the smallest I can go is to 0. And remembering that 365 is the reverse of 1 over n, so notice the pattern, okay? What I'm going to do is make this interval, now you're never going to have to do this again, I'm just trying to explain something to you. I want to make this number as I want to make n as small as possible. I want to make it go to 0. Okay, so I want n to go to 0, that thing you understand. I want Rn to be n to go to 0. In other words, I want continuous compounding. I don't want semi-annual, I want it smaller. I don't want quarterly, I want it smaller. I don't want monthly, I want it smaller. I don't want daily, I want it smaller. I want it instantaneous or continuous. This is the smallest interval, continuous. Now the reason why I had to reintroduce the R there is no, I can't write EPR of 0. Okay, I can't write that. It doesn't make sense because you can't instantaneously, effectively charge interest or compound interest. So that doesn't make sense. But this is the formula that represents the annual effective rate equivalent of that. Now, this ugly formula, you might have seen this, you should have seen this in calculus or something like it. This is a limit problem, and it turns out this limit problem is equal to something much easier and pretty, and that's why they use it. If we instantaneously accumulate, and this is a phenomenon that's visible in the physical sciences and it's used in finance because biologists and physicists became intrigued with finance, and they imparted And also financial economists also borrowed from the sciences these properties. And you see that this is simply equal to E. I'm going to put it on this side. The exponential function with R0 in the top. So you can have R0. R0 is the annual rate compounded continuously. That's what R0 is. ER0 is actually equal to this mess over here, which fits in the pattern of the string of equalities, making the interval smaller and smaller and smaller, smallest it can be 0. So I throw this on the end. I never introduce this formula to you again, so don't worry about the limiting formula unless you appreciate it. I do, and that's why I put it there. And now we can use it, because look at this relationship. It's exactly equal to 1 plus EAR. Okay? So we can exploit that relationship, and it is used in theory, in finance. The continuously compounded rate is used theoretically, and we teach you how to problem solve with it. Okay? So, any questions so far? You might be blown away. Maybe you saw this before. So the smallest interval is continuous compounding. It's infinite. It's infinitesimal. I don't know. I used to make drawings of this, but Kelvin's still asking me about the timeline. Okay, Kelvin, you have to ask me in a bit, okay? Let me finish this, and then let's look at that. Okay, so I'm going to open now 2.12. Okay, so here it is again. So 1 plus EAR is equal to this mess formula that is really essentially just the exponential function with the rate, the annual rate compounded continuously. So that is the extreme. And so what you take from there is just that 1 plus EAR, a factor of the effective annual rate, is just e to the R0. So you've probably seen this before, and maybe you understand it better now, I hope. So you can use it in this form, or I can rearrange that in this form. Depends on the question. Okay, algebraically, those are equivalent. So if we take the time value of money relationship, and I can specify, it doesn't necessarily have to start at time 0, right? I can start at any time t, and then as long as the duration of the investment is big T, I could find the future value. So this is just a more general expression of the time value of money relationship. So if I had the effective annual rate, that's how I would solve it. So this was just for I. This was general. If I have effective annual rate, that's how I would solve it. If I had the equivalent annual rate compounded continuously, that's how I would solve it. So you will see, this is used with options, derivatives known as options. You see this formula a lot. This is like the basis of the theory of pricing options. So That's what it looks like. So inside of here is basically your 1 plus, your 1 plus I. That's all I'm trying to show you here. So this is like the 1 plus I here. So let's apply it in a problem. I give you a problem below. So I'll let you work with that because it's already 12 o'clock and I didn't want to stay in there much longer. So work with that. And I think in the prep, the test prep, I give you questions on that. $2.15. Yeah, so you get some practice there. Yeah, that's about it. Nothing more complicated than that. Just understanding that 1 plus EAR is equivalent to the exponent being the continuously compounded rate, the exponential function with the continuously compounded rate, by the mathematical rationale of the limit formula. Yeah, the boxes. All right. So everyone who needs to go. Let me see if I can answer Calvin's question and whoever else has a question. Okay, Calvin, you're asking me the one of mixed cash flow, the second one of the first review. Oh, the second one of the first review. I don't see that. Are you sure it's the first review? Of what? Of the... Give me the document number. Give me the document number. Okay, bye everybody else. Unless you guys want to see this and you have nowhere to go immediately. Okay, 1.3. Okay, starting 1 year from now, we will receive $2,000 for each of the next 3 years and $3,000 for an additional 2 years. The timeline for this one? So starting 1 year from now, I can't even do it. It's so hard. I need a line. The line tool gets so wild. See, I can't turn it off. Okay, so starting 1 year from now, $2,000, so this is 2K. And then for the next 3 years, and then 3,000 per year for an additional 2 years. This is the timeline. K for 1,000. Does it? Is that sufficient? Does that make sense? Okay, very good, Calvin. The T at the end of the formula paper, what does it stand for? The T is the duration of the investment. Time, T for time. Is that okay? Any other questions? So I'm going to send all the solutions. You just keep everything in order. Your notes. Very good. So have a great weekend. Bye for now.